Blessed day to all. Welcome to my channel, Math with Mrs. O. I'm Ofelia Orate, principal owner of a school and a tutorial center, a math teacher and an author of 21 books. Before we start, please smash the subscribe button and the bell button so that we can notify you about our next video. Our lesson for today is slope of a line. Now, by definition, a slope is just the measure of the inclination or the steepness of a line. So, we normally denote a slope by M, which is the vertical change, vertical so up and down, over the horizontal change. We normally use this in mathematics to denote change. So this is change in y over change in x. So this is now equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now if you use y sub 1 minus y sub 2 over x sub 1 minus x sub 2, you'll get the same answer. Just remember that if you use y sub 2 here first, you also have to use x sub 2 first. If you use y sub 1 first, you use x sub 1 first to get the correct answer. Let's have some examples. First example is, what is the slope of this given line here? There are two ways for you to get the slope. The first method is by inspection method. You get the vertical change. You see that from 3, you go down. From 3, we go down. How many steps? 1, 2, 3. We go down 3 steps since we're going down. The change in y or the vertical change is -3. Over, from here, you go to the right 2 units. To the right is +2 because there are 2 units. Therefore, your slope is -3/2 or -1.5. That is by inspection. Again, let me repeat. From here, you go 1, 2, 3 down, so that's -3 over 1, 2 to the right, that's +2. So the slope is -3 over 2. Now, you can also use inspection starting from this point going up. So how do you go there? Vertical change here is 3 units going up, so that's +3. There, we go there, right? That is +3 units going up. And then we move to the left. It is left, so that's -2. So again, we got 3 from here, 3 up. So that's +3, 2 to the left, that is -2. So you still get -3/2 or -1.5. Another method is by using the formula up here. We can use y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. This ordered pair here has x component 0 and y component 3. Whereas this point here has x2 and y0 there. So you can let your x sub 1 be 0 and your y sub 1 be 3 for this, and for 2 2, 0, we can let this be our x sub 2 and 0 be y sub 2, and then plug in the values here. So you can have here y sub 2, which is 0, minus y sub 1, 3 over x sub 2, 2 minus x sub 1, 0. So 0 minus 3 is negative 3 over 2 minus 0 is 2. See, you're getting the same answer. Now, Mrs. O, what if I use y sub 1 minus y sub 2 over x sub 1 minus x sub 2? I'll show you. So if it is y sub 1, we get 3 minus y sub 2 is 0 over x sub 1 is 0 minus x sub 2 is 2. 3 minus 0 is 3 over negative 2. You will be getting the same answer, provided when you use y sub 2 here, first, it should be x sub 2 here. You can't interchange them. Problem number 2, example 2. What is the slope of the line passing through 3, 1 and 1/2 negative 6? So you let this be your x sub 1. This is now your y sub 1. This is x sub 2. And this is y sub 2. And then apply the formula. So y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Plug in the values. So y sub 2, negative 6 minus y sub 1 is 1 all over x sub 2, 1/2 minus x sub 1 is 3. Negative 6 minus 1 means negative 6 plus negative 1. So that's negative 7. Over 1/2 minus 3 is negative 2.5. If this was fast for you, you can do it slowly, like 1/2 minus 3 over 1. LCD is 2. 2 divided by 2 is 1 times 1 is 1. Minus 2 divided by 1 is 2 times 3 is 6. There. Then 1 minus 6 is negative 5 over 2, or negative 2.5. How did I get this fast? When you have negative 3 and then you minus 1/2, you simply get negative 2.5. There, or 2.5, and then copy the sign of the bigger number. Now, this is negative 7 all over. Make this an improper fraction. 2 times 2, 4 plus 1, 5. Negative 5/2. Then how do we divide fractions? Numerator times the reciprocal of the denominator. There, numerator times the reciprocal of the denominator. We get negative 14 over negative 5. This is simply 14 over 5, or 2 and 4/5. Let's check. 5 times 2 is 10. 10 plus 4 is 14. So this is now the slope of the problem in the second example. Let's move on to problem number 3. Example 3. Find the slope of line 1. Line 1 is a horizontal line. So therefore, this has coordinates. X is 2, y is 4. And this has coordinates. This is the x-axis, y-axis. So the coordinates here of this point are x is 0 and y is 4. We let this be x sub 1. This is y sub 1. And we let this be x sub 2. And this is y sub 2. So we solve for the slope using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's plug in the values. X sub 2 is 2. By the way, no. This should be y sub 2 rather is 4 minus y sub 1 is 4 all over x sub 2 is 2 minus x sub 1 is 0. Repeat, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. There. So 4 minus 4 is 0 over 2. 0 divided by 2 is 0. So as you can see here, always remember that let's have a generalization. The slope of a horizontal line, just like example 3, is 0. Any horizontal line will have a slope of 0. Let's move on to example 4. Find the slope of line 2, which is a vertical line. So, what are the coordinates here? We have x is 3, y is 0. What about this? This has coordinates. X is 3 and y is negative 2. There, 3 and negative 2. We use the slope formula again. So we have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Substitute the values. Let's say this is our x sub 1 and this is y sub 1. So this is x sub 2 and this is y sub 2. Let's plug in the values. Y sub 2, so negative 2, minus y sub 1, 0, over x sub 2, 3, minus x sub 1, 3. How do you observe? Negative 2 minus 0 gives you a negative 2 over 3 minus 3 is 0. So, whenever the denominator is 0, you have undefined. There. So, you see that the slope of a vertical line is undefined. So, let's have a generalization here. Slope of a vertical line is undefined. Remember that. So again, when you have a horizontal line, the slope is 0, but when you have a vertical line, the slope is undefined. When I was a student, I always remember this. Undefined, you have an F here, vertical. It's a vertical line. So when I see an F here, vertical line, the slope is undefined. 0, I have here a 0. Oh, here, it's like that, no? Z, like that. So it's a horizontal line. Horizontal line is 0. Those are just my way of remembering things when I was still a student. Example number 5. What is the slope of these two lines and this line? Okay. So, we use the slope formula again. So this is our x sub 1, y sub 1, x sub 2, y sub 2. Let's call this L3 and this is L4. Slope of L3, y sub 2, 4, minus y sub 1, 0, all over x sub 2, 0 minus x sub 1, negative 2. Let me repeat that. Y sub 2, 4, minus y sub 1, 0, all over x sub 2, 0, minus x sub 1. So we have here 4 minus 0 is 4 over Negative of a negative is positive. So, the final answer here is 2. The slope of line 3 is 2. Now, what about the slope of line 4? So, we have here, let's say this is y sub 2, negative 6 minus y sub 1 all over x sub 2 minus x sub 1. That is negative 6 over 5 over negative 5, or 6/5. 6/5 is 1 and 1/5. I will do analysis later. What about here? For L5, I will have to solve for the slope of L5 here. I get here 1 y sub 2 minus y sub 1 minus negative 4 all over x sub 2 negative 3 minus x sub 1. So we have here 1 plus 4 is 5 over negative 3, or this is negative 5/3. So this is the slope of line 5 equals negative 5/3. There, negative 5/3. Now let us analyze or give our generalizations. What did you observe here? When the line is leaning to the right, your slope is positive. Remember that. Whenever your line is leaning to the right, your slope is positive. How do we know that a line is leaning to the right? From left to right, it is going up here. Left to right, it's going up. Left to right, it's going up. So again, when a line leans to the right, just like these two lines, line 3 and line 4, the slope is positive. What about this? The line is leaning to the left. From left to right, it is going down. That would mean the line is leaning to the left. Do you see that the slope is negative? All lines leaning to the left have a negative slope. All lines leaning to the right have positive slopes. There. The slope of a horizontal line is 0, and the slope of a vertical line is undefined. Now, sometimes you will be given an application like this in example 6. What is the value of k so that the slope of the line passing through K4, 3 to K is negative 1? Simply apply the definition of slope. The slope, as per definition, is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Here, we let this be our x sub 1, and then this is our y sub 1, and let this be x sub 2, and this is y sub 2. Then plug in the values. Y sub 2 is 2k minus y sub 1, 4 all over x sub 2 is 3 minus x sub 1 is k. And in the problem, the slope is negative 1. Equate this to negative 1. Now, what do you see here? Over 1. You just cross multiply this, or multiply both sides by 3 minus k. It's the same thing. Okay? So that you will not get confused, let us multiply this by 3 minus k. It's the same thing as when you cross multiply. So 3 minus k times this 3 minus k cancels. You're left with 2k minus 4 equals 3 minus k times negative 1 is just negative 1 times 3 minus k. See, if you cross multiply them, 2k minus 4 times 1 is 2k minus 4. 3 minus k times negative 1 is just negative 1 times 3 minus k. See? So it's the same as you multiply 3 minus k to both sides. So now let's simplify. So this is 2k minus 4 equals negative 3 plus k. Combine the k's. So 2k minus k, this one, transpose it to the other side, equals negative 3 plus 4. I transpose k there, I transpose 4 here. 2k minus k is k equals negative 3 plus 4 is positive 1. There we are. So k is equal to positive 1. I hope I was of help to you. Before we end, let us remember to add kindness, subtract judgment, multiply understanding equals Mrs. O's good life equation. Don't forget, smash the subscribe button and the bell button. Thank you.